is you have to understand which way to put the sign when there's negatives. When you were a little kid, they taught you if there's a 2 and a 7 is clearly bigger. Alligator eats the bigger one. Okay, so that's, I think you already know that. I hope you know that. The alligator's mouth is open. He's eating the bigger one. But now you're older and you have to answer more complicated questions like, if this symbol is just sitting there without any numbers, or if it has an A and a B and you don't know what's bigger, well then what's the name of this sign? Well, that is called the less than sign. To me it looks like an L, so it's a less than. This does not look like an L at all to me. I mean, I kind of shades of an L, but okay, that's a greater than sign. So if there's no numbers around, you have to know how to say it. Next thing is if they put a little line here, that means or equal to. That means if you have a variable, because you can't be less than something and equal to it at the same time. Or you can't be greater than or equal to 8 at the same time. But if you have a variable, this is saying, I'll take things that are equal to 8, or I'll take things that are bigger than 8. Both. It's like this or this. There's no such thing as being this and this. But anyway, it's like an or thing. You could be bigger than 8, or you can be 8. All right, and one of these gets a solid line. I'd like you to please write this down, write this symbol down, and then write solid. One of the biggest mistakes I get is people have a solid line where they're supposed to have a dotted, or a dotted line where they're supposed to have a solid. That kind gets a solid line. Why? Because the things that are on the line are equal to 8. Okay, next thing. I get it. You have 50-50 chance. Is x equals 8 this way, the blue one, or is x equals 8 this way, the green one? Is it the blue one or the green one? It's the blue one. X equals go up and down, and here's a way you can do it. You should know this is the x-axis, and if you were to count over to 8, that is a spot right there. And then you have to decide to go straight up and down or left and right. And if you went left and right, you'd be saying x was 8 and 7 and 6 and 5 and 4 and 3. That doesn't make sense. It only works if you go up and down. Okay, and last but not least, you now have to shade your graphs. What? Yes, math keeps getting more complicated because you're getting older and smarter. So we don't just graph 2 lines and see where they cross anymore. We graph 2 lines and shade above them or below them. All right. The only exception to above and below, I mean, the green line, well, duh, you can shade above it or you can shade below it. Like, that's pretty easy. There's above and there's below. But the blue line, for the blue line, there's either right or left. And if something is, like I said here, bigger than 8, do you get that that's to the right of that blue line? I'm going to erase this green line because that was an example of how you don't do it. So there is my final graph for that problem. Did I use a solid line? Yeah, I did, and I'm supposed to. All right. So then, if you understood that, can you please graph for me y, notice not x, y is less than, notice, not less than or equal to, 2. Everybody please graph y is less than 2. If you're stuck, first think, where's y equal to 2? Put a dot where y equals 2. Here's where y equals 2. Right there. Putting a big dot there. And by using logic, I'm going to go, the other one was x, so this must be the way y goes. And I just got it wrong. Y. Yes? Dotted line. Why is math so picky? Well, if you were going to be a lawyer, literally the word or versus and in a contract could mean the difference of billions of dollars. The word or versus and. Okay, like if you read this contract and it said, I will give you the sum of $2,000 or I will replace your iPhone. And it says and instead of or. Well, then that just said you will give them $2,000 and I will replace your iPhone. That's a huge difference. And you do that times 1 million customers, you're talking billions of dollars because of a word and or the word or. So math is picky, yeah, but life is picky. You have one word different in a contract. It costs you $1 billion as a company. All right, so be careful. This one is a less than sign, and it is below the 2. And it's a dotted line because it doesn't say that it's equal to the 2. Now, would you please put in the other one also, the X graph that I already graphed? Just you graph it too. And the question then is, where do they overlap? All of your lines will cross. We're not going to be that mean to make parallel lines because then the lines would never cross and it gets really complicated. So your lines are always going to cross. You see where ours crossed? In this case, that is not really a super special spot. Last time when the two lines crossed, that was it. That was the holy grail. You wanted to find where the two lines cross, and then that's the answer. Here, it just means there's 4 different regions. This area here, nothing got shaded in that spot. So that is definitely not the answer. This next area, some of you are going to think that this is the answer right here in this green region because you see some shading in there. But is that the double shaded area? No. So that is not your answer. If you put a point in here, the way you can ask yourself is, are both lines shading towards my point? One of the lines is shading towards this point, but the other line isn't. See the one with the white shading here? That one's not shading towards that point. So that is definitely not your region. That's not it. That's not it. And I probably can guess which one is it. I'm going to use yellow again. It's this area right here because it's got white shading in it and it's got yellow shading in it. So you pick any point in there, any point, doesn't matter if it's in there. That's going to be like the point 15 comma negative 2. 15 comma negative 2. That point works because it's shaded. It's in the shaded area where both of them are shaded there. And if I stick in 15 and 2 in my equations, x is 15. 15 really is bigger than 8. It works. And if I take the other equation here and I put a negative 2 in here, negative 2 really is less than 2. It worked. The signs are correct. So here's the big picture. Old days, you would graph a line. You would be done. Now you have to ask yourself, should it be solid or dotted? If it's a less than or equal to, it'll be solid. This kind is solid. Greater than or equal to, also solid. These kind are solid lines. If instead it's just a less than or a greater than, those are dotted lines. If you're taking notes so that you can remember this at the key moment on the test, that would be smart to put that in your notes. Solid ones have an equals. Dotted ones don't. All right, so this must be, since I used a solid line for this graph, it must be one of these two. And if you want to shade below something, that's what's less than. Now, I totally get, when you're looking at these two, you can get confused on which of them is the less than sign. This one looks more like an L. It's the less than sign. And so I would shade below the line. Greater than, you would have shaded above the line. So in the old days, you just graph it. Now you graph it, figure out if it's solid or dotted. In this case, it was solid because I said it was this symbol right here. And that is one of the solid symbols. And then it was less than, so you shade underneath it. But what if you shade another line? Okay, here's another line. And this time it shades this way. That's less than. Because if it's straight up and down, you can't shade below it or above it. Less than is to the left, and that makes sense. It's intuitive. Then do you see the double region? Stare at the double region up here. Which is the double shaded region? Were you staring at this region right here? Is that where you were looking? Because that's where it was double shaded. So any point in there would be a solution. 0, 0 is in that side of the line. That means 0 would solve both equations. Stuck in 0, 0 into both equations, it would have worked. The signs would be correct. If you understood that, this should be absolutely doable. Graph both lines. Figure out if they're solid or dotted. Figure out if you shade above it or below it. And when you're done, the two lines will have crossed. And there's 4 little regions. You pick the right region where they're shaded double. To get you started, start at -6. Then rise -1 and run 1. Down 1, over 1. Down 1, over 1. Then figure out if this should be a solid line or a dotted line, and which way should you shade. Okay, I'm going to pause. I'm going to be making sure that you're trying this. All I can ask is that you try. Okay, I think most of you guys knew this was a dotted line. And by the way, I'm okay with you just using dots when it's a dotted line. Like drawing over this with a dotted line is kind of, extra. Don't have to do that. Now, if it was meant to be like this one and a solid line, you do have to draw a line through it then. Okay, but for this one, the top one, I'm just going to shade, it says less than, I'm going to shade below it like this. Notice, you don't have to shade all the way over the whole graph. Just shade a little bit in that direction. All right. Now the other one. Walk me through this. Remington, do you know how to graph this thing?
Yeah.
Tell me what to do.
Y-intercept is -2.
Check.
And then slope is 3, so you rise 3, run.
Rise 3, run 1, rise 3, run 1, rise 3, run 1, rise 3, run 1. And I should probably keep going like that. Ooh, I hit it. Can I stop? No. Keep going down 3, over 1, down 3, over 1. Goes off the graph a little bit. That's okay.
It's not dotted.
It's solid. Very good.
You shade above the line.
It says greater, so I shade above. And then it's really common for a kid to get this far and then screw it up by not telling me where's the answer. This alone is not the answer. You've got to pick where is the region. There's 4 regions. Is it region 1? Is it region 2? Is it region 3? Or is it region 4? That's your answer. Region 4. That's where it got double shaded. Any 2 lines cross, you get 4 regions. They don't have names. Good kid asked me last year, they have names like quadrant 1, 2, 3, 4. Nope, they don't, because they aren't straight lines. But there could be thought of as 4 different regions. So you don't have to label them 1, 2, 3, 4. I'm just trying to make the point that the answer is here. And you got to somehow make that clear. I just really shade it really dark, and that works. But if you don't show me which one it is, you got super close to right, and then you'll get it wrong. You got to tell me which one is the answer. You could even, like, if you wanted to make it extra clear, it's like, answer. You could do that. That'd make it really clear. The answer's in that zone. Now, some kids got confused last hour because I kept on taking a point, and they thought there was like some magic on how I picked the point. I'm just going to pick a random spot, like right there. Any spot that's in that region can be tested to show that it works. That spot right there is at -6, -2. That's its name. -6, -2. So if I put in -6 and -2, -6 for the x and -2 for the y, these symbols will be right. -2 really is less than those two negatives. Do you see that there's two negatives here? There's a negative there, and there's a negative on this 6 that I just put in. That makes this +6 minus 6. 6 minus 6 is 0. Now, there is often a question of, like, what's bigger, -2 or 0? And I kind of get it. Some kids are like, 2 is bigger than 0, so I think I'm going to pick the -2. For this, because this is going to come up, like, literally the first question on the homework has something like this. Which one's bigger? And it can be confusing. Whichever one is warmer is bigger. And you guys are Minnesotans. You know that temperatures can be below 0, and you know which one's warmer. That one's warmer, so that one's bigger. Alligator eats the bigger thing. It goes like that. Okay, so if you're confused on what's bigger between these two negative numbers, the one that's warmer is the one that's bigger. Okay. So this time, the only difference is you're going to have to get this solved for y. It's going to be on your test at least 3 times where you have to solve for y. Please take a second, solve this one for y, and then it's just like the other one. Please practice this. We're done in about 5, maybe 4 minutes now. Solve it for y by adding 3x to both sides. Another way to say it is, I'm going to move the -3x to the other side. And deep in the recesses of some people's memory, they're like, wait a minute, there was a negative sign. Does that mean I should switch the sign around? No. If you multiply or divide by a negative, did I multiply by a negative? Nope. I added 3x. That does not cause my sign to switch around. But when you multiply by a negative, you do. There, I've solved it. Now graph this and this. One of them's dotted, one of them's solid, one of them you shade above, and I think in this case, you shade one below and you shade one above. Done? Put it on the keyboard. Math rewards careful people. Will you be careful enough on this next test? There almost might be a correlation between how much you get paid and how careful you have to be. If your job doesn't require you to be careful at all, it might be really an easy job. If you're a brain surgeon and you by accident go an extra centimeter in the wrong direction, you could cause somebody to like lose all of their memories. That's bad. So being careful is critical. Now, there's times to be careful and there's times to not have to worry about it that much. On a test is your time to worry about it and be extra careful and double check. A daily lesson in math, make a little mistake, it's not a big deal. But when your test comes up, early part of next week, some kids are going to forget the dotted line. Some kids are going to shade on the wrong side of the line. Some people will forget to switch the sign from less than to greater than when they multiply by a negative. All right, I'm going to graph this top one. It starts at 6. The slope is -1/1. Some kids think you move the opposite in both directions. That's not true. It's -1, so it falls 1, but it always runs to the right. So the rise will be -1, but you always run to the right. Down 1, over 1, down 1, over 1, down 1, over 1. Just keep going with the pattern. Now, solid or dotted line? Lila? Solid. Zariah, shaded above or below it? Yep. The other line. Asen, tell me how to graph this. Let's do it quick. Start at the 2 and then what?
You go up by 3.
And over?
1.
Yep, I already hit it. Should I stop?
No.
I'll make a whole bunch of dots that do that pattern. Now, Asen, solid line, dotted line? Dotted. Do you remember me saying I'm okay with you just leaving dots then? Then I'm going to put a little, like, arrow at the end of this one and an arrow at the end of this one, and there's my line. I'm going to put a dotted line through it just because I want to make sure it doesn't make some math teacher mad at me. Okay, now, Asen, shade above or below? Above. There's region 1 that isn't shaded at all. Duh, not the answer. There's region 2, region 3, and region 4. Those are not official names. I'm just trying to point out there's 4 areas that could be your final answer, and it's region 3 that ended up winning because it gets shaded in double shaded there. It gets shaded in green and got shaded in red. So the way I would do that if I had different colors is I'd pick a new color and like really darken that area. And there we go. That's your new stuff for today. Shading graphs, making sure that they're either dotted or solid, and finding final answers like where they overlap. All right, so now you have a worksheet. It is simple. It is just great practice, and you have the rest of the hour to finish that. I'm going to ask people to come up and get some help. Sometime, if you want to come up because you have a question, awesome. Otherwise, I'll be inviting a few people up to make sure you got this down. And that's all I got for you for today.